Minash-shaytanir-rajim. Bismillahir-rahmanir-rahim. Today we will solve unit number 4 exercise, and last time we have discussed some problems. Today we will solve other problems, and for this we have some important formulas like we have before, and in the addition there are some new formulas, and then we will solve our problems. And here is the formulas, important formulas. First is a rectangular component, and fx is equal to f cos theta, fy is equal to f sin theta, magnitude of force, this direction of anything, tan inverse fy over fx, torque force into L, और condition of equilibrium हमने पढ़ा था. There is a sigma f is equal to 0, sigma torque is equal to 0, and the force have a two terms, sigma fx is equal to 0, sigma fy is equal to 0. Now the new formulas for we will use in the next problem. These are the principle of movements, and clockwise movement is equal to anti-clockwise movement, or we can say that W2 multiplied by moment arm of W2 is equal to W1 multiplied by moment of W1. And the next one is that weight. Weight, we know that W is denoted and is equal to mass into gravity, and the last one is that tensions is equal to weight. Today we will solve problem number 6, and the problem number 6 statement is that the picture frame is hanging by a two vertical strings. The tension in the strings are 3.8 Newton and 4.4 Newton. Find the weight of the picture frame. There we are given with a tensions, and we have to find the weight. By this statement, the given data is, here is data. The tension T1 is a 3.8 Newton and the tension T2 is a 4.4 Newton. Weight of the frame we have to find. As we know that the total weight object is always equal to the forces or tension acting on it. Then we can say that the W is equal to T1 plus T2, and now we use T1 3.8 plus T2 4.4, and W will be equal to 8.2 Newton, that is the weight of the string. Next problem statement is that the two blocks of masses 5 kg and 3 kg are suspended by the two strings as shown in the figure. Find the tension in each string. There are two masses and attached by a single string, and we have to find the total tension in these objects or in these strings. First we will use for only a one object, and that is, first we have to find the tension of this, and second one this separately, then we can find whole tension of the object. Firstly we will use it up to us which we take first, this one or this one. We will take first this one, then we can get the whole tension. The given data is big block mass 1 m1, that is a 5 kg, and the small box m2 is equal to 3 kg. We have to find the tension in each string. Solution: as we know that the weight of the objects is equal to tension, we know very well that weight is always equal to m into g. If we are finding for the first object, any you can take according to diagram. Here is a box that is a 5 kg, and here is another object that is a 3 kg. It's up to us which we take first. We are taking mass 1 and m2. First we have to find the 10 weight of this object, and weight of this object is equal to m into g1, and g is gravitational acceleration, and that is equal to 10 meter per second square. By this formula we can find mass is equal to m1 g, and the weight will be equal to m1 is 5 multiplied by 10. The total weight of object 1 is 15 Newton. That is a weight of this one. Similarly, we will find the mass of another object, and that is a m2. Now we take block. Okay, W is equal to m2 g, and that is equal to tension T1, you can say that, and the first one is tension T2 or tension T1, here you can say. Okay, now T2 is equal to W is equal to m2 is 3, and that is equal to 10. T2 is equal to W is equal to 30 Newton, and we have to find tension in each string. Each string means there are a single string. The total tension will be equal to the total weight. Now we can solve this. Tension in a string is equal to weight W1 plus W2. W1 is equal to 50 plus W2 is equal to 30. Then the tension will be a 80 Newton. That is our problem. Next question statement is that a nut has been tightened by a force of 200 Newton using 10 centimeter long spanner. What length of a spanner is required to loosen the same nut with 150 Newton force? According to this statement, the given data is force of tighten the nut 200 Newton F1, moment arm, or we can say that the distance between the length spanner, moment arm L1 is equal to 10 centimeter. Force to loosen the nut F2 is equal to 150 Newton. We find the length of the spanner L2. As we know that the principle of movements, and we have a relation that W2 multiplied by movement arm of W2 is equal to W1 multiplied by movement arm of W1, and movement arm is according to the length. That's why now we will use the values, and W2 or F2, we can say that weight or a force is same, and we will say that the force is equal to the weight. So that's why the this relation can be like this. F2 R, both terms are same. F1 multiplied by movement arm of F1. We have to find the L2, that is F2 L2 is equal to F1 F1 multiplied by L L1. Clear? No, by putting the values, we know that F2 is 150 multiplied by L2 we have to find, and F1 is 200 Newton and the L1 is 10. We have to find this L2. That will become a 2000 and 150. 150 here it is multiplication, and we will take another side, it will be divided, is equal to 150, and the answer will be is 13.3 centimeter, and that is the length of the spanner by which we loosen a net.